Python idle basics. The Python idle lets you write a line of code at a time before executing. It can be used to test short lines of Python code rather than running an entire script. To open idle, go to the Windows taskbar, type in idle and select it from the search items. This will open the shell window. Python can automatically handle multiplication. In the shell screen, type 1 + 1 and press enter. This will return the calculation of the sum in the row below. Here you can see that the input text which you typed has an arrow next to it to show that it's an input line and the output text doesn't. To divide, we use the / symbol. If you type in 5 divide by 2 and press enter, you will see that it brings back a float, which is just a number with a decimal point. If we want to bring back a whole number, otherwise known as an integer, then we could type a double / between the 5 and 2. Now it will bring back the integer value of the sum. Another way to do this would be to convert the output value of the sum into an integer by typing int, then an open bracket, then 5, then /, then 2, then closed bracket, then press enter. Whilst this may look like a longer method to use, sometimes we will need to convert our code into different formats mid-program, so knowing how to convert values this way is useful. If we want to specify the output to be text format rather than a number, then we would need to convert the code into a string. We do this by placing str in front of the code and enclose the sum in brackets. We can stack these type conversions together. For example, if we convert the sum to an integer and then convert it to a str, we lose the decimal point as well as convert it to a string type. Now that the output is a string type, we can join other strings to it. Notice that strings have to be placed between 2 apostrophes. We can also place them between speech marks, which works in the same way. The output also has the text in apostrophes so that we can easily see that it is of the type string. To multiply numbers together, we can type the asterisk, otherwise known as the start symbol. To minus numbers together, we can type the hyphen symbol. When doing complex equations, it is best to place all individual parts of the sum within brackets. E.g., if we are adding 1 and 1 together and summing it with the value of 5 divide by 2, we would type open bracket 1 + 1, close bracket, plus open bracket 5 divide by 2, close bracket. As we are working in the Python shell screen, we can't save any of the work that we have done. In order to save code and build out a program, we need to create a savable script. To do this, we can go to File and select New File. This will open up a blank script. This is where we can code larger programs. Whilst we're in a script, the output of a script still gets displayed in the original shell window whenever we run the program. But we do need to specify when we want a value shown in the shell window. To do this, we use the print method. Type print open bracket 5 + 5, close bracket. Then click on Run and select Run Module. You will then get a pop-up that asks you to save the script. The script needs to be saved before it can be run. Here I will just name the script test. Once saved, the script will run. Notice that the output is printed to the shell window. Our script is now located in the saved location. If we navigate to where we saved the script and go to View and click File Name Extension, we can see that the file type is a .py type. This means that it is a Python script. If we double-click the file, notice that command prompt will load and close shortly after. This runs the script, however the printed text is not displayed. This is because the print function is mainly used for debugging within the Python shell, so has to be opened with idle for it to display properly without closing straight away. If we change the file extension from a .py to a .pyw, this means that the command prompt won't open when running. We can open py and pyw with Python idle by going to File and Open, then selecting the script. If we wanted to store a value or calculation in our script so that it could be used later on in the script, we would need to assign that value to a variable. Above the print statement, we typed earlier type variable 1 = 5 + 5. Then change the print statement to print variable 1. Then press Run module. This does the same thing as we did previously, however it now refers to the variable when printing rather than doing the calculation in the print function. Now that we have a variable created, let's create a new variable in the script window called variable2. Type equals then 10. Now on the next line down, create a variable named variable3 and type equals variable1 variable2. Then in the print statement, change the value to variable3. Then run the module. We can see that in each variable an output is calculated, then the variables are summed together. Python automatically assigns types to variables based on the values that are contained within them. In this case, variable 1, 2, and 3 are all integers. After the print statement, create a new variable called variable4. Then type equals, then apostrophe, then space, then MySum, then apostrophe again. Then create a new variable called final. This will add variable 3 and variable 4 together, but as variable 3 is a int and variable 4 is a string, we will need to convert variable 3 to a string first. Here we can write equals str open bracket variable 3. Then type plus, then variable 4, close bracket. This will create a new variable with the converted variable 3 into a string type. It doesn't, however, change the original variable 3's type, so if we use variable 3 in future it will still be a type integer. Now type print open bracket final closed bracket, then run the code. We can now see that both strings have been concatenated together in one final output. Python runs through code in the order that it is written. Here we can see that the first print statement is executed, then another line is executed for the second print statement. Knowing the order that the script is ran can be important when building lengthy programs. We can reassign a variable's value by retyping the variable name, then typing equals. So, let's say we want to change the value of variable 3, we could write variable 3 equals 20. Now, the value of variable 3 will be changed to 20, but only when it gets to the line of code in the script that specifies that. So, when the script runs, initially variable 3 will equal a sum of variable 1 minus variable 2, but then later on variable 3 will be assigned the value of 20, so whenever we refer to variable 3 in future it will have the value of 20. When assigning a value, we can also refer to the variable itself. For example, if we now write another line of code that says variable 3 equals variable 3 plus 2. The updated variable will take the previous value of 20 and add 2 to it, updating the value of variable 3 to equal 22. If we write a print statement now, to print variable 3, then run the script, we can see that 22 is the value listed in the third output print statement.